All right, students, as we do learning from home, or if I use this in future years, um, we will be using this whenever in classroom. But to give you some context, um, we are in the COVID coronavirus learn from home. So, when we're out of this in future years, I said, wow, that's why Mr. Demratz is doing this from home during the day. So, Unit 9, Earth, Sun, Moon systems, Earth's days, years, and seasons. Starter. How are the Earth's days, years, typo, and seasons related to the way Earth moves in space? The way Earth moves in space is gives us so many things. It gives us days, it gives us seasons, it gives us years, it gives us climates. Really, a lot of the reasons why we're able to live on Earth the way we know it is because of the way the Earth moves and spins through space. Here are our wonderful SOLs. They're fantastic. You can actually pause the video and read them yourselves. Vocab. When I do these, I'm just going to read the vocab. If you need to pause it to write it down, you pause it and write it down. Rotation, the spinning of a body, such as a planet on its axis. An axis is an imaginary line through a spinning object that it rotates on. It's almost like you would put like a stick in the middle of the ball, and that's what it spins off of. Day, the time it takes a planet to complete one full rotation on its axis. Rotation means days. When you hear the term rotation, you think a day because the time that it takes the Earth to go completely around is 24 hours, and we like to call that a day. What determines the length of a day? The Earth spins on an imaginary straight line that runs from the North Pole to the South Pole, from the very top to the very bottom. The Earth rotates in a clockwise motion, and only one half of the Earth faces the sun at any one time. That does not change. If you were to put a basketball in front of a light, half of it is in the dark, half of it's in the light. No matter how much you spin it, no matter how much you tilt it, half of it's facing the sun, half of it is facing away, and it is dark. When you face the sun, it's daytime. When you're facing away, it's nighttime. Common sense. It takes 24 hours or one day to complete one rotation. Rotation, rotation, spins, rotation, rotation. When boys, when you throw a curveball, you are trying to get rotation on the ball. All right, so I had to embed the videos to get this to work. So let's give a listen as this wonderful crash course videos. I'm going to explain this to you visually as I'm trying to do it orally.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts.
Okay, I'm going to skip the demonstration on there. It's basically she's just putting that's not quite the best demonstration you probably did in elementary school. Here's a great picture of the Earth tilted on its axis when it says 23.5 degrees, a straight line North Pole, South Pole. Well, it's a straight line North Pole, South Pole. But what it is, it's tilted. So this angle right here is 23.5 degrees. This area right here, there are multiple reasons why. Right now it would be winter here and it would be summer here. This guy's leaning forward. This guy's getting longer days. That's very important. You're going to hear about this later in the video. They're also getting more direct hits from the sunlight. Less direct hits, glancing blows, shorter days, cold. Revolution. The motion of a body spinning around another body. A revolution. Year. The Earth completes a full revolution around the sun in 365 and 1/4 days. That is why we add an extra day to our calendar every year. Yeah, interesting point. Revolution. Well, people talk about revolution, but technically it comes right back to where it was. Just interesting history spot. What determines the length of a year? The Earth revolves around the sun at a speed of about 30 kilometers a second. That's how fast we're moving in space. 30 kilometers a second would mean from Liberty Middle to downtown Richmond in a second, one Mississippi. Richmond, there. That's how fast we're moving. We divide the year into 12 months that last between 28 and 31 days. That's the way they set up the calendar. Don't ask me why, just the way they did it. Earth's orbit is not a perfect circle. We're about 2.5 million kilometers closer to the sun in January, but it does not affect our temperature much. People think, oh, we're closer to the sun, it's going to be hotter. No, that is not the reason why. In fact, we're closer in January, so you would think in the Northern Hemisphere, oh, it's going to be warmer, but that's not the way it works. This video is the same video I just showed you. If you want to rewatch it, you can go ahead and rewatch it. There is an example of our orbit around the sun. It's a revolution. One revolution, but what's cool is we're actually closer. Those are millions of kilometers right there. So we're actually closer. Well, I think it's miles on this one. The 151 million miles, 146. We're actually 5 million miles closer in January than July, but July is much warmer on this in the northern hemisphere. Southern hemisphere, it's actually warm, it's actually cold in July and warm up here. So it's the opposite. But the thing to say is this is an ellipse and it's not this exaggerated. It's more like this, but it's not a perfect circle. And believe it or not, the sun is orbiting around something too in outer space. It is moving, but that's real heavy duty space science. But just to know, we are moving around the sun, but it's not a perfect circle. What conditions are affected by the tilt of the Earth's axis? The Earth's axis is always tilted at 23.5 degrees. Why? Speculate. Some people think when our Earth was forming, it got knocked by a really, really big rock, and this rock became part of the Earth and tilted us on its side. The axis is always pointing at the North Star. That is why it's kind of set in the sky and it's to the north. So if you camp a lot, you can find the North Star and kind of get your bearings if you don't have a compass or a working iPhone. There, once again, is the tilt of the Earth's axis. Northern, southern. Tropics are right here. Tropic seasons are not that much. Remember I said I had the visitor? They had never really seen snow. They'd never seen leaves fall off trees. That's because they live in the tropics. We live in temperate climate right up here. Here is a temperate climate. We have changing seasons, leaves fall off trees, they regrow, all that stuff. But what's cool up here, here's the Arctic Circle. As this spins, you can see down here it's spinning. Would this area ever go dark right now? Would this area ever go light? If it doesn't go light or dark, what's happening there? And does that flip or reverse during the revolution? What conditions are affected by the tilt of the Earth's axis? Temperature of the Earth is affected by the direct or indirect strike of the sun's rays. When we are in summer, we are tilted towards the sun, and the southern hemisphere is tilting away. They would have winter. We have the opposite seasons. What we're having in Virginia is the opposite of what they're having, the opposite in Australia, in New Zealand, and southern South America, and southern Africa. The equator is getting a much more consistent direct hit from the sun's rays than the polar regions. So let's get a little example of this. There's actually a really
about the coldest season.
There's actually a really cool demonstration in this video that if we were in school during the COVID, I'd be doing with you guys, but you guys have to watch it.
Here are the cold scientific facts, beginning with the start of winter. Winter officially arrives on the shortest day and longest night of the year, known as the winter solstice. It lands between December 21st and 22nd for those living north of the equator. But why does it get so cold? We're all taught it starts with the Earth's orbit.
Something to do with the angle
These people
of
are
the
wrong.
Earth and the sun.
In the winter months, we're pretty much out here, further from the sun.
Because of the air masses that move across certain latitudes.
But I think we're just further away from the sun.
The real reason it gets cold isn't the distance, but the angle of the Earth to the sun.
Well, it's colder in the winter precisely because of the low sun angles. It really comes down to how strong the sun is.
Like a spinning top frozen in an off-kilter position, the Earth is tilted on its axis, fixed at 23.5 degrees. As we orbit around the sun, the North Pole is angled furthest away from the sun on the winter solstice. Think of the sun like a flashlight shining on a piece of paper. Directly overhead, the light is concentrated. At an angle, the same amount of light is spread out and less concentrated. It's the same with the sun. The Earth stays colder because the sunlight's warming effect is less intense. Much like sunrise and sunset are cooler than noon.
You experience this every day. Morning and dusk are cooler times of the day than noon. High noon, you can feel the sun right over your head beating down on you. But in the morning, when it's low on the horizon, those rays come in at an angle rather than straight overhead. And it's that angle that makes those rays less intense.
All right, solid video. I like that flashlight thing. So here, flashlight is hitting us at an angle, not actually right there, it's more direct rays. Right here, flashlight's hitting us at an angle. So this is what it looks like when it's winter in northern hemisphere, summer in the southern. Summer in northern, winter in the southern. They have the opposite of what we have. Mailman just came. All right. What conditions are affected by the tilt of the Earth's axis? Daylight hours are also different at the equator. The sun sets at about 6 p.m. every day. The equator is different. Our sunsets change. In fact, the sunset in Virginia will be a different time than New York City or Miami, Florida, or up in Maine, just because of where we are on the Earth. In the Arctic Circle, there are days where the sun never sets or it never rises. This slowly changes the more north you move. So, a cool thing with Siri. Siri, what time is sunset today in Richmond, Virginia?
Sunset will be at 7:39 p.m. today in Richmond.
7:39 today in Richmond. Siri, what time is sunset today in Miami, Florida, directly south of us?
In Miami, Florida today, sunset will be at 7:41 p.m.
Different time. Siri, what time is sunset today in Portland, Maine?
In Portland, Maine today, sunset will be at 7:16 p.m.
Different time. So we have different times depending upon where you are on the planet. I'm going to try this one. Siri, what time is sunset today in Brazil?
Sunset will be at 6:08 p.m. today in Brasilia, Brazil.
6:08. Always around 6 o'clock in Brazil. Siri, what time is sunset today in Nome, Alaska?
Sunset will be at 10:17 p.m. today in Nome, Alaska.
So Nome is getting many more daylight hours than Brazil, and we're going to see that later on. So this is a cool video. This is called Midnight Sun. If you ever want to do some traveling to way up north, you can have days that never end and you can have nights that never end. Well, they eventually end, but it takes a long time. So here we see on the map, that is Barrow, Alaska.
Well, I can tell you this. There are not too many places on the face of the earth where you are going to see a sun in the middle of the sky at 1:30 in the morning, which is the local time here right now in Barrow, Alaska. It's 1:30 in the morning, and it's 32 degrees. It is May 30th. Brilliant. 1:05. Oh, sorry, I thought it was 1:35. All right, it's 1:05 in the morning. 32 degrees. And you can see that all week it's supposed to be nice too.
Nice.
And look at that. Look what time it
Well, get this a little
says
closer.
that the sun rises and sunsets.
Sunrise at 12 a.m., sunset at 12 a.m. The phone understands the sun's not going to set there today. Pretty interesting. On the opposite end of the Earth, at the South Pole, there will be towns that would have all night. They would not see the sun for days, weeks at a time, on certain times of the year. So this is a midnight sun. That sun won't set. It won't get dark there for weeks. A very interesting place to live. And here you see right here, this is where it would have been in Alaska. It's not going dark. Down here will go dark. But when it tilts the opposite way, that same town that has midnight sun, they're going to have days of 100% dark as well. So you won't see the sun for days upon time, days on end. Very interesting place to live. A season is a pattern of temperature and other weather trends. Equinox. Sunlight shines equally on the northern and southern hemispheres on a day in March and September. The solstice. Sunlight is at its maximum in one hemisphere and the minimum in another. An equinox happens in the spring and the fall. That means we get the same amount of day and night. Solstice means we have days that are the maximum amount of sun. We have days in the summer we'll get 13 hours of sun and 9 hours, that's not right, 24 hours. We'll have 13, there'll be days we have 13 hours of sun and 11 hours of dark. We might have 15 hours of sun and 9 hours of dark. In the winter, we might have 15 hours of dark and 9 hours of sun. So our day's length actually change. What causes seasons? As the earth travels around the sun, did I miss something there? No. As the Earth travels around the sun, the amount of sunlight directly hitting each portion of the planet changes. This solar energy will make the ground and water warmer for a period of time. The length of days, it's going to warm up. But someone might say, well, Mr. Demratz, why, if it's always so cold, if it's 24 hours of sun in the North Pole, why doesn't it heat up? That's because it's hitting at an angle. Remember how that's flashlights? It wasn't very bright in that one spot, but as you take it over, it becomes less. So we're going to watch this one for a little bit until I feel it starts to lose you. All right. Can I go full screen? I'm risking this. I don't want to do this again.
When I was a kid, my understanding of the seasons was that December and January were cold and covered with snow. April and May were bursting with flowers. July and August were hot and sunshiny. And September and October were a kaleidoscope of colorful leaves. It was just the way the world worked, and it was magical. If you had told me back then that 1/3 of Earth's population had never seen snow, or that July 4th was most definitely not a beach day, I would have thought you were crazy. But in reality, seasonal change with 4 distinct seasons only happens in 2 regions on the planet, and even in those 2, the seasons are reversed. But why? A lot of people have heard of an astronomer called Johannes Kepler and how
You
he
will.
proved that the planetary orbits are elliptical and that the sun is not at the center of the orbit. It was a big deal when he figured this out several hundred years ago. His discovery solved a lot of mathematical problems that astronomers were having with planetary orbit measurements. While it's true that our orbit's not perfectly circular, those pictures in our science books, on TV, and in the movies give an exaggerated impression of how elongated our orbit is. In fact, Earth's orbit is very nearly a perfect circle. However, because Earth's orbit
But
is
it's not
technically an
perfect.
ellipse, even though it doesn't look like one, and the sun isn't quite exactly at the center, it means that our distance from the sun does change through the year. Aha! So winter happens when the Earth is further away from the sun. Well, no, not so fast. The Earth is actually closer to the sun in January than we are in July, by 5 million kilometers. January is smack dab in the middle of the coldest season of the year for those of us up north. Still not convinced? How about this? Summer and winter occur simultaneously on the surface of our planet. When it's winter in Connecticut, it's summer in New Zealand. So if it's not the distance from the sun, what else could it be? Well, we need to also know that the Earth doesn't sit straight up. It actually tilts. And that axial tilt of the Earth is one of the main reasons for the seasons. The Earth spins on an axis that's tilted 23.5 degrees from vertical. At the same time, the Earth revolves around the sun with the axis always pointing in the same direction in space. Together with the tilt, the spinning and revolving causes the number of hours of daylight in a region to change as the year goes by, with more hours in summer and fewer in winter. So, when the sun is shining on the Earth, it warms up. After the sun sets, it has time to cool down. So in the summer, any location that's about 40 degrees north of the equator, like Hartford, Connecticut, will get 15 hours of daylight each day and 9 hours of darkness. It warms up for longer than it cools. This happens day after day, so there's an overall warming effect. Remember this fact for later. In the winter, the opposite happens. There are many more hours of cooling time than warming time, and day after day, this results in a cooling effect. The interesting thing is, as you move north, the number of daylight hours in summer increases. So Juneau, Alaska would get about 19 hours of daylight on the same summer day that Tallahassee, Florida gets about 14. In fact, in the summertime at the North Pole, the sun never sets. Okay then, it's all about daylight hours. I've got it. Well, no. There's another important piece to this puzzle. If daylight hours were the only thing that determined average temperature, wouldn't the North Pole be the hottest place on Earth in northern summer? Because it receives 24 hours of daylight in the months surrounding the summer solstice. But it's the North Pole. There's still icebergs in the water and snow on the ground. So what's going on? The Earth is a sphere, and so the amount of solar energy an area receives changes based on how high the sun is in the sky, which, as you know, changes during the day between sunrise and sunset. But the maximum height also changes during the year, with the greatest solar height during the summer months and highest of all at noon on the summer solstice, which is June 21st in the northern hemisphere and December 21st in the southern hemisphere. This is because as the Earth revolves, the northern hemisphere ends up tilted away from the sun in the winter and toward the sun in summer, which puts the sun more directly overhead for longer amounts of time. Remember those increased summertime daylight hours? And solar energy per square kilometer increases as the sun gets higher in the sky. So, when the sun's at an angle, the amount of energy delivered to each square of the sunlit area is less. Therefore, even though the North Pole is getting 24 hours of daylight to warm up, the sunlight it receives is very spread out and delivers less energy than a place further south, where the sun is higher in the sky because it's more tilted toward the sun. Besides, the North Pole has a lot to make up for. It was cooling down without any sunlight at all for 6 months straight. So, as the seasons
No
change,
sunlight
wherever
for
you are, you
6
can now
months?
appreciate not just the beauty of each new season, but the astronomical complexity that brings them to you.
Always a good solid video from Ted Ed. And there we go, tilt of the sun, solstices, and all that fun stuff. Summer solstice, spring equinox, winter solstice, autumn equinox. This last video, well, I'm sorry, let me go back just for a second. Oh no, I'm sorry, let me pull it this way. The length of a day is determined by Earth's rotation. The length of the day is determined by the Earth's revolution around the sun. Earth's tilt affects temperatures and daylight hours at different locations on the Earth. So this last TED Ed, I mean, it gets kind of complicated with the position of the sun. It makes a figure eight. There is some pretty cool art going on in it, though. I really like the way they designed the video. So if you want to watch it again, you can watch it again. If not, you can stop the YouTube channel because it's going to go over some of the stuff we've already done. Thank you, students. Let's click this on.
Suppose you placed a camera at a fixed position, took a picture of the sky at the same time every day for an entire year, and overlaid all of the photos on top of each other. What would the sun look like in that combined image? A stationary dot? A circular path? Neither. Oddly enough, it makes this figure-8 pattern, known as the sun's analemma. But why? The Earth's movement creates a few cycles. First of all, it rotates on its axis about once every 24 hours, producing sunrises and sunsets. At the same time, it's making a much slower cycle, orbiting around the sun approximately every 365 days. But there's a twist. Relative to the plane of its orbit, the Earth doesn't spin with the North Pole pointing straight up. Instead, its axis has a constant tilt of 23.4 degrees. This is known as the Earth's axial tilt, or obliquity. A 23-degree tilt may not seem important, but it's the main reason that we experience different seasons. Because the axis remains tilted in the same direction while the Earth makes its annual orbit, there are long periods each year when the northern half of the planet remains tilted toward the sun, while the southern half is tilted away, and vice versa. What we experience as summer and winter. During summer, in a given hemisphere, the sun appears higher in the sky, making the days longer and warmer. Once a year, the sun's declination, the angle between the equator and the position on the Earth where the sun appears directly overhead, reaches its maximum. This day is known as the summer solstice, the longest day of the year, and the one day where the sun appears highest in the sky. So the Earth's axial tilt partially explains why the sun changes positions in the sky, and the analemma's length represents the full 46.8 degrees of the sun's declination throughout the year. But why is it a figure 8?
This is a little complicated. I'm not going to have you know this, but
this is due
I
to
like
another feature of the
this
Earth's
video.
revolution, its orbital eccentricity. The Earth's orbit around the sun is an ellipse, with its distance to the sun changing at various points. The corresponding change in gravitational force causes the Earth to move fastest in January, when it reaches its closest point to the sun, the perihelion, and the slowest in July, when it reaches its farthest point, the aphelion. The Earth's eccentricity means that solar noon, the time when the sun is highest in the sky, doesn't always occur at the same point in the day. So a sundial may be as much as 16 minutes ahead or 14 minutes behind a regular clock. In fact, clock time and sun time only match 4 times a year. The analemma's width represents the extent of this deviation. So how did people know the correct time years ago? For most of human history, going by the sun's position was close enough. But during the modern era, the difference between sundials and mechanical clocks became important. The equation of time, introduced by Ptolemy and later refined based on the work of Johann Kepler, converts between apparent solar time and the mean time we've all come to rely on. Globes even used to have the analemma printed on them to allow people to determine the difference between clock time and solar time based on the day of the year.
I
just
can't
how
even
the
imagine
analemma
trying to read
appears
that.
depends upon where you are. It'll be tilted at an angle depending on your latitude, or inverted if you're in the southern hemisphere. And if you're on another planet, you might find something completely different. Depending on that planet's orbital eccentricity and axial tilt, the analemma might appear as a teardrop, oval, or even a straight line.
It's pretty wild. All right, students, thanks for watching. Hopefully everything's cool with where you're at. And thank you. Let me give it a pause. And I am going to... Oh, don't glitch out.